feeling like you're living in the shadow of your former self? Don't have the cores to scale with your buddies? Frustrated with your lack of ability to scale that app, and your throughput is on its way down? You might not be getting slower. You might simply have a treatable condition called low scalability, or low S.
Allows you to do things to respond to the business quickly. And you know, this is one of the most unique things that I think Microsoft brings to the table as a partner of yours. At Microsoft, we operate more than 200 cloud services that are serving hundreds of millions of users around the world. We literally deploy servers into our data centers in the hundreds of thousands at a time. Why is that relevant? Why is that important? Well, you better believe we learn, and we learn an incredible amount as we operate these incredible cloud services and as we operate Azure. And our commitment to you, and what I think really differentiates us more than any organization and over any other partner you could partner with here is we are committed to bringing every single thing that we learn as we operate these services in the public cloud to you to run in your data centers. So innovations that we're doing in the hardware, innovations that we're doing in the operating system, in the virtualization, in the application, in the management, in the process, bringing all of that to you so that you can benefit from that and then being consistent across clouds, which I'm going to talk about in a little bit more. So as we were designing these R2 releases, a couple of big design principles for us. First, almost every organization we talk to tells us they're going to be running multiple clouds or consuming capacity from multiple clouds. So the ability to make it easy and seamless for you to consume multiple clouds and just stretch and have a data center without boundaries was one of our principal design features. I couldn't think of a better way to term the next one, but it's just cloud innovation everywhere. Innovation in storage, networking, compute, in the workloads, stretching the infrastructure out to Azure and stretching the infrastructure out to your service providers. Literally, cloud innovation everywhere. And what this delivers is the ability for you to deploy your applications dynamically, quickly. You know, literally, ladies and gentlemen, these R2 releases we're talking about with you today is us bringing the things that we're doing on these cloud services and in Azure to you. That literally is what we're doing. So again, today what we're pleased to announce is Windows Server 2012 R2, System Center 2012 R2. And we want you to see how some of the organizations have been using the assets that we have been building. Since we're in Spain, we thought this would be a great one for us to talk about. Telefonica, one of the world's largest organizations, and doing some incredible innovation in their data centers and what they're doing as they really consolidate their infrastructure. Let's take a look at how they're using the Microsoft capabilities.
We're at a catalyst point in the telco industry. Everybody needs to be connected all the time now. The mission for Telefonica is to connect people. We have 340 million different customers around the globe. So it's connecting people. It's not just telephony, it's data, it's applications. Managing over 50 data centers globally between different companies we've acquired, very complex. Telefonica's vision is to make that much more simple. The strategy over the next 3 years, starting this year in 2013 in Europe, is to consolidate down 27 data centers. These will eventually boil down and rationalize and virtualize down to 3 rooms in our brand new Madrid data center that we've just completed.
There are only 8 Tier 4 data centers certified by Uptime Institute in the world. By size, ours is the largest.
It doesn't take a rocket scientist to realize when you bring that down and highly virtualize, increase density to an ultimate state, the sort of savings in power, cost, efficiency and operation that brings.
The reason why we are looking for an alternative to VMware is to reduce the cost and to find alternatives aligned with the most used operating systems in our company.
Late last year, we ran a pilot on the brand new version of Hyper-V. Incredibly impressed. We then decided very quickly with the results to put into the middle of our virtualized platform in this Tier 4 data center. Now with Hyper-V, we can actually scale the solutions to what we need, whether it's 1,000 users or 100,000 users. It doesn't matter.
You can imagine the benefits if we are talking about 18,000 different virtual machines running on the same fabric in about 75–80% of utilization.
Our strategy as Telefonica is a hybrid cloud, so it will neither be all private, it will neither be all public. What we love about using the Hyper-V product and using it internally, it gives us complete flexibility to mesh ultimately into the Azure product as and when we need it. So our strategy is very, very attuned to Microsoft. As we go on this spectacular journey, if you imagine a vision of 18,000 servers virtualized in a world-class data center on a world-class platform, fundamentally, with all the data in one location, supporting a Telefonica hybrid cloud vision with a Microsoft Cloud OS vision, actually these things mean that anything is possible.
Wow. I mean, really, wow. 18,000 servers being consolidated down to 1,600 servers. The world's largest Tier 4 data center. Tier 4 means everything, absolutely everything is redundant. 5 nines of guaranteed service. That means 5 minutes of downtime a year. Okay, and I love some of the comments that they gave in there about the challenges of bringing everything together, doing that on top of Hyper-V because VMware was just too expensive. If you ever had the question, is Hyper-V and the Microsoft Cloud capability ready for prime time, ready for your mission critical? Certainly the answer is yes. And so I'd encourage you to really take a look at that. But it gets better. So today, again, the availability of the preview bits of Windows Server 2012 R2 and the entire System Center Suite 2012 R2 available for your download today. Okay? Yeah, come on, give it up. A big deal, everybody. Less than a year, we've turned around major releases, and I can tell you one thing, we've done a heck of a lot more than a year's worth of innovation in these products. I think when you get a hold of them, you get a chance to see what we've done in there, using these cloud-first design principles and using some of these new changes in our processes where we literally learn from the cloud and bring it to you, you're going to see an incredible amount of value delivered in a very, very short period of time. Let me talk for a minute about our strategy about hybrid cloud. When we talk about hybrid cloud, fundamental and at the core of everything we do is a belief that you should just have consistency across your clouds. Consistency for virtualization, for your developers, for your management, for identity, for data. Consistency, consistency, consistency. Now, why is this important? None of you want to be locked into a cloud. You want to have the ability to move your applications, your virtual machines between a private cloud, a service provider, Azure, at will in a friction-free environment. And by delivering consistent capabilities across those clouds, that's what you get when you use the Microsoft Cloud Operating System capabilities. You don't have to go through a migration. You don't have to go through a translation of the VMs. You can move your VMs at will, friction-free, because we are delivering consistency across those clouds. And as we have built these R2 releases, we've considered all three of those clouds, assuming that most of you will run in a hybrid T environment. Now let's get specific in one of the examples. This morning we're also announcing the availability of what we call the Windows Azure Pack. The Windows Azure Pack is quite literally taking the capabilities that we've been developing and running on top of Azure on top of Windows Server for your benefit. So things like the ability to do high-density web server hosting. Okay, in Azure, we host 4,000 or 5,000 web servers on a single Windows Server instance. You have that capability with the Windows Azure Pack. The experience, when you come up to Windows Azure and you get that self-service experience in the portal, that portal experience delivered to you to run in your data centers for your customers to take advantage of. In Azure, there's a set of capabilities called Service Bus. And Service Bus is this ability to take your applications that are using multiple clouds and keep that all in sync, delivering Service Bus to all of you to run in your clouds. Those are the kinds of capabilities that you get with this Windows Azure Pack. And again, at its fundamental base is delivering consistency and our learnings from Windows Azure to you to run in your data center. So let's take a look at some of these capabilities. And what we want to start out showing you is this incredible experience that's been pioneered on Windows Azure for use in the public cloud, and how we're going to bring that for you now to run in your data centers, for your customers, for your tenants. Let's welcome Claire to the stage. She's going to give us a demonstration of the Windows Azure Pack.
Thanks, Brad. Good morning. It's an honor to be here today and show you the Windows Azure Pack and how Microsoft is delivering consistency across clouds. With the Windows Azure Pack, we take code that was built for the cloud, in the cloud, deliver it to you. Add Windows Server, add System Center, and you have an integrated stack, a stack to build your clouds, clouds that are consistent with Azure. Let's take a look. Right away, this looks just like Azure, and as Brad said, I have the same ability to deploy high-density websites, virtual machines, SQL databases. But take a closer look. This is the Contoso Cloud, built on the Contoso Windows Server and System Center infrastructure, and I've logged in today using my Active Directory credentials. Taking a look at some of my deployments here, you can see I have a couple of standalone virtual machines. These could be Windows Server, they could be Linux distributions. I also have this new virtual machine role. This new role type allows me to take an application, deploy it into the virtual machine, and then scale out using multiple instances. Next, I'd like to show you how easy it is to provision one of these new virtual machines. Go into my gallery, and because I'm logged in as Claire, I'm presented with the set of IT-approved workloads. With the Windows Azure Pack, we simplify your ability to create these standard offerings. And as you might expect in my data center here, I have some of the most common workloads: Active Directory, SharePoint, SQL Server. I want to deploy a new web portal, so I'm going to choose IIS. Move through my wizard here. I provide a name. Next, I'm given this opportunity to choose a version. This ability to version allows you as the IT administrator to start delegating and automating those post-deployment maintenance activities. Think software update, patching. Moving through the wizard, I'm next presented with a scoped set of options. Things like initial instance count, my VM size, my hard drive size, my network configurations. As the IT administrator, you set these options. This is where you embed your policies and yet at the same time give your customer the right set of choices. I've finished with my credentials here. My password, confirm my password. Now my virtual machine is configured. The next thing to do is to configure the application. And those workloads and applications you saw in the gallery, each one has a unique set of configuration parameters. What I'm looking at here are specific to IIS. I could go ahead and confirm these and take the defaults and start the deployment. Instead, that takes a few minutes, so instead what I'd like to do is show you the other dimension of self-service, and that's management. So going back and looking at this particular virtual machine that's deployed, I'm going to go ahead and click on it. And you'll see that I get some really great insight into my current usage patterns. Notice I've just deployed a couple of cores out of the 50 that are allocated. I've barely started using the memory and storage that's been allocated as well. Take a look. My IT department has provided me with an update. Now, I could, with a simple click down here, I could choose to update now, or I might want to wait till it makes more sense for my business. Now, think for a minute about all of the changes that constantly occur in your business. As the line of business owner, I want to have the flexibility to scale out and then scale back in to meet this constant flux and this constant change. I currently have 2 instances deployed. With a simple click, I could quickly deploy a 3rd, a 4th, or a 5th. Today, I just want to deploy one more, so I simply hit Save, confirm my deployment, and now the deployment has started. And because this is powered by Windows Server and System Center, you can rest assured it is fully automated, yet bound within the parameters that you've set. What I have shown you today is truly unique in the industry. Combine your skills with the integrated stack of the Windows Azure Pack, System Center, and Windows Server, and you have the right combination, the combination to build what's next in your organization. Thank you and have a great week.
All right, thanks, Claire. All right, so let's go a little bit deeper now. So you talk about this consistency across clouds. And as we think about this consistency across clouds, we really kind of think about it in 2 ways. We think about the infrastructure itself, the fabric, so work that we're doing in compute, storage, and network. And then we think about it in terms of the workloads. And this also actually translates into 2 different experiences as well. There's an experience for the IT people who are building the fabric, and then there's the experience for the consumers of the cloud. And that's what Claire just demonstrated to you, was showing you that exact same experience that we have in Azure, now that you can use for your users, whether that be the line of business, your dev test, or if you're a service provider, your tenants. Okay? And that's that upper half of this. And we've done a lot of work on the workloads. Now, interestingly enough, there's a couple of things I want to talk about, some significant announcements today. First of all, we're announcing a world record in an SAP configuration. So since 2011, Windows has been the platform that holds the record for the most scalable, or the world record of SAP configurations. On Friday, we published with Hewlett-Packard the world record of a 3-tier SAP configuration running in a 2-socket box, 30% better than the world record that VMware had published a couple of years ago. So again, this is on today's technology. This is on Server 2012, and we're going to show you in a couple of minutes how it even gets better in these R2 releases. And another significant announcement, and this is with Oracle. And this is one of those examples, I think, of 2 organizations doing exactly the things that all of you, our customers, want. We're announcing a partnership with Oracle, where this is really about making sure that you can take the Oracle workloads, and they will be fully supported on the Microsoft Private Cloud on Hyper-V, as well as in Azure. Okay, you're going to have license mobility, so if you have Oracle licenses and you want to move those to Windows Azure, with this partnership, you now have the ability to do that. Okay, we're going to have a fully supported Java running inside of Azure from Oracle, and then we'll actually be putting out some of the standard configurations for the Oracle workloads, like Database and WebSphere, and those will actually appear in the Azure gallery. Okay, so a significant partnership with Oracle and Microsoft, again, doing what all of you expect of us to do, making these things run together in a very, very effective way. Now, again, that's on today's technology. I want to talk now a little bit more about the bottom half of this diagram on the right, and I want to talk about some of the things that we've been doing in the fabric. Okay, I talked about cloud innovation everywhere. You know, one of the things when you're operating these large clouds, and again, you're deploying hundreds of thousands of servers, you know, you innovate and you innovate. You automate, because everything has got to be automated. Anything that requires human intervention is cost, is time, and is an opportunity for error. For example, in Azure, we make more than 50,000 network changes a day. Everything has to be automated, and you are relentless in automating and driving efficiencies and driving out cost. Okay, now how are we bringing this to you? What we're going to show you here in a minute is some of the things that we've done in these R2 releases. Things like the ability to do a live migration between two different versions of Windows Server with zero downtime. Innovations in storage, where you get scale-out, high-availability storage on commodity, cost-effective hardware. Okay, now, you know, we're not saying we don't like SANs. You know, we know we're going to be using SANs for a long time, but in our cloud services at Microsoft, everything runs on standard direct attached storage. And through the magic of software, we're delivering a lot of the capabilities, or the capabilities that historically you've had to go to SANs for, on commodity, cost-effective hardware, driving your costs down. And then from a software-defined networking standpoint, the ability to do tenant isolation, the ability to seamlessly stretch your organization out to a service provider or Azure, and then wrapping all of this up with things like disaster recovery, backup, high availability to service providers across your own data centers or to Azure in the box with these R2 releases. So just an incredible amount of innovation in the fabric. Let's spend a few minutes looking at that. Let's invite Jeff here. He's going to come and show you what we entitle here Cloud Innovation Everywhere, and show you some of the innovation. Give him a hand.
Thanks, Brad. Buenos días, Madrid. Es un gran placer estar aquí esta mañana. Muchas gracias por su hospitalidad. Windows Server and System Center 2012 R2 are about making your business more agile, your data center more flexible, and providing you cloud-optimized infrastructure. Let's start by taking a look at storage. In Windows Server 2012, we introduced Spaces to provide flexible pooling of disks to provide flexible, fault-tolerant storage. In Server 2012 R2, we're taking Spaces to the next level by dramatically improving performance and scale while lowering your cost per gigabyte and, more importantly, per I/O. Let me show you. Here, I've got a 17 terabyte pool. This pool consists of 20 hard disks and 4 SSDs. The hard disks provide me capacity, while the SSDs provide me fantastic I/O performance. Now, wouldn't it be great if the storage just automatically moved the hot blocks from the hard disk into the SSD? Well, we think so too. That's why we're introducing automatic storage tiering into Windows Server 2012 R2. Let me show you. Let's go ahead and create some tiered storage out of my pool. And I'm going to create storage tiers. And now it's going to ask me, do I want a simple or a mirrored layout? I'd like a mirrored layout for better reliability. Now I can go with the 2 or the new 3-way mirror for better resiliency. And now it's going to ask me to specify the sizes of each of the tiers. Now, to keep it simple, I'm going to choose the maximum size for both the SSD and the hard disk tier. And just like that, I've created my tiered storage. Now, to show you the performance impact of tiered storage, what better way to do that than with a SQL load test? Here, I have a couple of servers, identically configured except to different back-end storage. One of them using a direct attach, the other one's using the Windows file server. You can see right now that the Windows file server delivers spectacular performance. In fact, it's on par with direct attach storage, delivering over 7,400 IOPS per second. But now, let's run the same test, this time with storage tiering enabled. Make sure you're holding onto your seats for this one, because we've just gone from over 7,400 IOPS to over 124,000 IOPS with storage tiering. That's over a 16x performance improvement. Keep in mind, to deliver this with traditional storage, you'd need over 360 15K SAS drives. We're doing this with 20 hard disks and 4 SSDs. So now that you've seen how we're going to reduce your cost per I/O, let me show you how we're going to reduce your cost per gigabyte. Let's go over here to our volumes, and you can see I've got two volumes, D and E. And in fact, these are identical, and they're filled with a whole bunch of virtual machines for a VDI deployment, except that you can see that volume D is nearly full, while volume E is saving almost over 230 gigabytes because it's using Windows deduplication. Now, wouldn't it be great if I could use my deduplication with running virtual machines for a VDI deployment? Of course, to do that, you'd want to ensure that there's no performance penalty. Well, what if I told you we could give you deduplication and actually improve performance at the same time? Sounds too good to be true, right? Well, let me show you. Let's go to the split screen for just a moment here. And here you can see I've got 10 virtual machines. 5 of these virtual machines are running on deduplicated storage. The other 5 are running on non-deduplicated storage. In the split screen, you can see the connection windows, so you can see the virtual machines as they're booting up. Now over here, we have this little tool. This just actually started all the VMs simultaneously. The other thing it's doing is it's monitoring the IP addresses. So what you can see is you can see the virtual machines as they're booting up. And you can see that the VMs running on dedupe storage are booting up faster. A lot faster. In fact, over twice as fast. How's this possible? Well, with deduplication, we know where all of the common blocks reside. So this gives us the opportunity to do intelligent caching, which means not only do you get better storage efficiency, but you get better storage performance with deduplication. Speaking of better storage performance, last year at TechEd in Europe, we showed something the world has never seen before. Last year, we demonstrated in Hyper-V that we're able to deliver over 1 million IOPS from a single virtual machine. Those were 4K IOPS. This year, we're going to raise the bar. This year, I'm going to run the test again. This is using Windows Server 2012 R2, but this is using 8K IOPS. And what you can see here is we're delivering over 1.6 million IOPS from a single virtual machine. This is over a 60% performance improvement, and we're delivering over twice the amount of data because we're doing this with 8K IOPS. All of this built into Server 2012 R2. Now let's get to one of your favorite topics, live migration. Now, in Windows Server 2012, we led the industry by providing the first hypervisor with shared nothing live migration. Now we're going to lead the industry again, this time in terms of live migration performance. So here, I'm going to start a couple of live migrations. And in fact, in all of these tests, I'm using the same virtual machine. The VM has 8 gigabytes of memory assigned to it, and it's running a SQL workload inside the VM. The VM is actually running really hard, it's under load, and there's constant memory churning. The first test is using Windows Server 2012. The second one is using Windows Server 2012 R2, and it's using live migration with compression. With compression, we're taking advantage of the fact that servers ship with an abundance of compute hardware, and the fact that we know that Hyper-V servers are rarely compute bound. So we're using some of those compute resources to compress the VM in line during live migration, which means it's more efficient, and in fact, it's much faster. And in fact, it's already done. Now, we could have just stopped there. Live migration compression is awesome, but we didn't. You see, in Windows Server 2012, we also introduced another new technology, SMB Direct, using RDMA. And we delivered that in the file server. That allows us to deliver fantastic performance for the file server. So now we're going to start up the third test. This time we're using live migration, using SMB Direct over RDMA. Again, the same exact virtual machine, and we're done. Not only was it done faster, but it was done with no CPU utilization because this was all done with RDMA. So that's just a couple of live migration capabilities. As Brad mentioned, we also have cross-version live migration as well. So finally, let's get to one of your other favorite topics, Hyper-V Replica. Now, Replica is our in-box, easy-to-use virtual machine replication built into Windows Server 2012. And we've been listening to your feedback very carefully. In fact, you've told us quite honestly you love it. But you do have a couple of requests. Number one, you want to be able to manage it at scale. But number two, more importantly, you want to be able to manage it across sites. So for example, here I'm using Virtual Machine Manager and System Center to manage my on-premises private cloud. However, this is in Madrid, and I also want to be able to do site migration and disaster recovery to Barcelona or Shanghai or New York. So we've heard you loud and clear. We understand that. And we want to provide you that centralized management console to orchestrate your replication across site. That's why we're introducing Hyper-V Recovery Manager. Hyper-V Recovery Manager is that orchestration that allows you to replicate and manage your replication across multiple sites. Hyper-V Recovery Manager is an Azure service, so there's no complexity, there's nothing to install because it's already waiting for you in the cloud. Now, one important point I want to make about Hyper-V Recovery Manager is the replication is still point-to-point. None of the replication that goes to Azure, Azure Hyper-V Recovery Manager just orchestrates the replication. So as I just showed you with VMM, I was showing you that I was in fact running a whole bunch of virtual machines on my premises. Well, in fact, here are those same protected items here in Contoso Corp. And in fact, here's my primary site. And I can quickly come here and see that all of my virtual machines are being protected. I have a quick glance and go. In addition, to do site migration and disaster recovery, you want to make sure that you're being able to do it in a systematic and orchestrated way. You want to make sure that you bring up groups of virtual machines in the correct and prescribed order. That's why we have recovery plans. You can think of this as your runbook in the cloud. So for example, I have a pre-failover step. In fact, this is a script. In fact, here's my first set of virtual machines, here's my second set of VMs, and so on. So it's not only virtual machines, it's scripts, and these could even be manual tasks. And what happens when that day arises when you want to perform that site migration or a disaster recovery? You simply click here on failover. I'm going to click on plan failover. I'm going to confirm the site that I'm migrating to, and I'm going to click on OK. Just like that, I'm migrating to my second site. One other thing to point out, since this is all running on Azure, I could have done all of this from my phone. DR and site migration has never been this easy. So think about what you've seen: storage tiering, deduplication, live migration capabilities, Hyper-V Recovery Manager. These are just a few of the dozens of reasons why Windows Server 2012 R2, System Center 2012 R2, and Azure is the best way to cloud optimize your business. Thank you very much.
Great job, Jeff. You know, one of the biggest challenges we had with putting this keynote together is that there is so much innovation in these R2 releases. Just kind of trying to select what we wanted to kind of show you was amazing. So we take full advantage of the week and actually go to the sessions, get your hands on. The reality is, I think many of you are actually downloading the bits in the room right now because the wireless has just been flooded here in the last hour. So let's just summarize real quickly. As you think about the transformation in the data center, literally taking the things that we're learning every day, day in and day out, inside of Azure, in these 200+ services, bringing to you to run in your data center, giving you the ability to have a data center without boundaries, innovating everywhere in the hardware, storage, networking, compute, in the workloads, partnerships with the key workload providers around the industry. These are the kinds of things that we're delivering for you to run in your data center. So think about what we talked about here in the last 90 minutes. We started talking about the work that we're doing to enable your users to be productive on their devices and some of the things that we're allowing you to take advantage or enabling you to take advantage of the BYO trends. We then talked about the innovations in what we're doing from an app platform in Visual Studio and in Azure to enable you to build even better apps and more rich apps than in the past. Data and gaining insights from those data through the work in SQL. And we just ended with the work that we're doing and how we're helping you to transform your data center. Now, it's interesting. People will ask me, Brad, what's Microsoft's vision around the cloud? It's really simple. Our vision is what we call the Cloud OS. And that's what we spent the last 90 minutes talking about. The Cloud OS delivers 4 promises. It enables you to empower what we call people-centric IT. It allows you to build modern or rich applications. It enables you to unlock the insights from any data. And it allows you to transform your data center. That is the promise of the Cloud OS. That's the promise we're making to all of you. We will enable these promises through the work that we're doing and enable you to do that across your clouds, service providers, and into Azure. Now, also just think for a minute about just the number of announcements you've seen this morning. a refresh of every one of the products and services that enables this. Windows Server 2012 R2, System Center 2012 R2, new version of, or new update to Windows Intune, Visual Studio 2003, SQL 2014. New versions coming out, a rapid pace of innovation, incredible value, incredible innovation coming from Microsoft. This is the kind of value that you can expect to see us deliver time and time again as we really take these things that we're doing in Azure and these cloud-first design principles and bring to you. Now let's take a look at how one organization is using the entire spectrum of these capabilities, and let's take a look at how Aston Martin is using the Microsoft Cloud OS.
The Aston Martin IT department that I came into was one that offered support. And what I needed to do was change that to an IT department that actually offered something more than that. It offered advice, it offered strategy, it offered innovation.
What we wanted was a single vendor who could provide all of the tools that we needed across our complete infrastructure.
At that time, cloud started to become very prevalent. Aston Martin needed to start developing strategic partnerships. Microsoft were a very key partner for that. What we can now offer is that service to the organization to say, what is it you want to do? And we'll help you innovate. What the Microsoft Cloud OS vision allows me to do is offer them slicker, quicker, faster ways of doing what they want to do and doing it very, very well.
Successfully deploying Office 365 gave us the confidence to explore some of the other new Microsoft products, which are cloud-based.
We moved our website to Azure. Fantastic support, fantastic solution, and we're looking at moving more out to the Azure cloud. What I want to do with Azure, what I want to do with Office 365, what I want to do with Intune is to enable the decision makers to make their decisions and make them quickly and make them with the right information in their pockets. We have more of a hybrid solution, so we do have a lot out in the cloud now, but we do have to look after what is actually within our own premise. The management of cross-platform dependencies is now starting to grow as well.
So the Cloud OS is going to allow us to develop not only our internal cloud environment, but also to be able to push into a hybrid for business continuity, disaster recovery, and so on. The hybrid strategy that we're implementing now is going to give us the best solution for the business. Windows Server allows us to focus less on the infrastructure and more on the strategic needs of the company.
What I want is for those individuals who are at that board level to have the ability to make their decisions, to surface the information they want. We have delivered that within Aston Martin. We'll continue to do that by using the Microsoft offering. What really drives me as the head of IT for Aston Martin is what comes out of the door every single day. We produce absolutely stunning and beautiful cars that are revered across the globe. If we can improve that, increase the decision making, why would I not be happy doing what I'm doing?
Let me just take a moment and offer our condolences to Aston Martin. You know, as many of you know, there was a tragic accident at the Le Mans 24-hour race, and one of their drivers died. And just our thoughts and prayers go out to the entire Aston Martin family. But when you think about Aston Martin, what comes to mind? Quality, right? Quality and luxury. A couple of interesting data points. In the new Vanquish car that they have, there's over 1 million stitches in the interior of that car. This is actually the 100th year anniversary of Aston Martin. In their history, they've built 65,000 cars. Listen to this statistic. 90% of those cars still exist today. Quality, luxury in everything they do, and that certainly is the perspective that their IT department has. And I'm proud to talk about how they have embraced working with us, the spectrum of capabilities across their entire spectrum, with what our vision is with the Cloud OS. So thank you for being here. You know, on behalf of all of Microsoft, you know, we so appreciate the ability to partner with you and your businesses. It is truly an honor, and it's a stewardship that we take incredibly seriously. And again, I just want to express just how grateful we are to be able to work with all of you. Now, in terms of continuing the conversation, one of the things I hope that you will do is immediately following this session, there's what we call a foundation session for all of those major areas. So depending upon what your specialty or your area of focus is, whether it's in, you know, people-centric IT, in data, in development, in the cloud platform, I would strongly encourage you to attend the foundation sessions that start right after this. You'll get a deeper click in all the demos. You're going to get a deeper click in all of the new announcements that have been made today. And that's a great way to start off, TechEd Europe. Again, thank you. Thank you for being here. Have a wonderful, wonderful week.
Is this on? Hey guys, due to the late, obviously just finish of the keynote, we'll be starting in 7 minutes time. So thanks for being timely, and 7 minutes time we'll get started. Cheers. Am I on? Great. We'll keep going in the next couple of minutes, but rather than just have you sit in silence, let me see if I can play some fun video. Well, there you go. Don't try that at work, or at least don't try it on my dime. Welcome, everybody. Thanks for coming along. You are in the Modern Business Application session. My name's Scott Woodgate. It's great to be here. Really appreciate you guys coming along to this session, which is focused on modern business applications. What are modern business applications? We're going to be talking about the application platform. I'm going to be spending a lot of time talking about the breadth of the platform, because this is a foundation session. The depth of individual topics will be covered in deeper breakout sessions. In terms of the breadth of the platform, I'll spend a fair amount of time on Azure. We'll spend time on Visual Studio. We'll spend time on Team Foundation Server. And we'll spend a little bit of time on SQL. Okay? So that's the center of this. I'm going to spend relatively little time in slides and a lot of time in a single integrated demo scenario, which I'll walk you through. Having said that, just to reframe, and I think Brad did such a great job in the keynote that I don't need to spend any time here. When we're talking about modern business applications, we're talking primarily from a developer lens. And the things that are important there are, as Brad described earlier, getting things done faster. Okay, so what we can do in the software, in the tooling, in the deployment processes to enable you to get things done faster is critical. Enabling you to, of course, attach across multiple devices, enabling you to access data from wherever it comes from, and then finally building the solution that you build that's both secure, which is kind of table stakes for many years, and available, in which there are many more options for availability these days with things like elastic scale in the cloud than there used to be. So enough on the marketing slides. What I really want to go to is more of an architecture level and then take you down into a tour of a solution through code. So first things first, really the building blocks of any application for many, many years. I could have been here, practically, I probably was here 10 years ago actually, giving a presentation, talking about enterprise architecture, and I could have talked to any of these particular building blocks. Of course, each of the building blocks, whether it be presentation, business logic, the networking, integration, identity, etc., have had massive innovation in the last 10 years. If you think about presentation, just as an example, a presentation that it goes through from a less than standard to a standardized approach with HTML and JavaScript. Presentation as it terms to rendering on big devices, small devices, phones. Tons of innovations happened in the presentation space. The same is true with any of these other buckets, identity being an obvious one, identity from Active Directory, identity from Google or Facebook or Microsoft. So within each of these squares, there's a ton of innovation going on. And that's interesting, but it's not really the point of my talk. What I find really interesting is if an application is composed of these building blocks, and that's the logical architecture, where do I deploy those? And historically, the answer to that question, where do I deploy this logical architecture, was really quite straightforward. I deployed it in my data center, okay? Or I deployed it on a rich client device talking to something in my data center. And today, there is much more choice in that, and it gets you thinking about how you can take advantage of some of these new compute models and how it relates to what you have today. So to give you an example of that, many folks in this room have virtualized your servers, right? And when you're virtualizing your servers, you can run that in premises, you can run that in public cloud. So when do you do that? When do you run one in the public cloud? When do you run one in premises? And the interesting thing about virtual machines that I talked about is actually they're portable. From an application perspective, if you think of the container as a virtual machine, you can decide whether you're putting it in the cloud or putting it on premises or developing it in the cloud and moving it back on premises production or vice versa. And you have complete portability. So this leads to a much broader set of architectural options to think about where parts of your stack are deployed when you're building applications. And the virtual machine aspect is interesting, and I'm going to spend time on development and test. But the space I really want to focus on here is not so much when do I use on-premises and when do I use public cloud, but how do I use both of those together? Okay? Public cloud is nothing cool, amazing, new, exciting, be-all, end of the world, amazing. It's another set of enterprise capability that I have. Okay? It's the next wave of the next set of enterprise capability that I have. How do I include that in my portfolio, just like I included all the other innovations? And that typically means, how do I take advantage of what I have on premises and new features in public cloud? And when should I use which? Just to give you a loose view on some of the decisions you would make when you're building your applications on when to use which. If we look at both of those, public cloud and on premises, in the context of some decisions. So from a reach perspective, if you're deploying something in the public cloud, you have substantially larger reach than most. Maybe Telefonica has pretty large reach with the number of data centers they have, but then most customers have, okay? Because you have the global data centers around the world and the reach available to that from something like a Windows Azure. So if you're looking for high reach, then the public cloud has an advantage. Similarly, if you're looking for availability, the public cloud has an advantage because there's infinite scale from your perspective in the public cloud. Our job is to keep the public cloud continually stocked with servers ready to run customer workloads so that from your perspective, the public cloud has infinite scale. You can run whatever you want on it at whatever size you want. On the other hand, if I think about security, there's some data that I want to keep really close to my chest. This depends on the organization and their risk tolerance. It may be compliance reasons that drive data needing to be in a specific location, or it may be the desire to keep things like financial or healthcare information within my data center. That's okay. Security typically favors, in terms of where I put my data, the private data center, as opposed to the public cloud. When I think about time to market, in fact, if this is the one takeaway you get from this whole session, the time to market by using the public cloud is really fast. It's really fast. I think many of us have got into a view of what normal looks like and how long it takes to deploy infrastructure on premises. The public cloud redefines normal for you, and that's a big win for the public cloud. Clearly, the existing state, however, is 99.9% on premises. So how do you manage with that? And then manageability is an interesting one, because you need manageability to span both the public cloud and span through to the private cloud, and do that in a single user experience so that I can manage these two environments as one, once I've built applications that take advantage of the best of both worlds. So hopefully that gets you a little bit thinking about some of the decisions I would need to go through as I'm thinking about building an application on reach, availability, security, and the like, on where I would deploy pieces of that application when I'm building what's sometimes called a hybrid application that spans my on-premises environment, my data center, and the public cloud. So with that, I'm going to take you through a little example here. This example is actually modeled on a customer in this region, which is EasyJet. So EasyJet is a customer that uses actually Windows Azure for their ticket ordering process. They do about 52 million transactions, last I looked, on EasyJet per year. And so I've taken the concept of EasyJet and made a demonstration little website here, which I'll find the right one, on a similar but related scenario. So here's the scenario. So I'm an existing ticket seller. I sell tickets to events, sporting events. And I already have an on-premises, public-facing website infrastructure to sell tickets. However, I have a problem. My problem is there are some upcoming events that my existing infrastructure can't scale to. And I actually built this demo for TechEd in the US, and so nearly nobody knew what rugby was. But I'm sure some of you in the audience will guess that I'm from New Zealand, and the only sport is rugby. And so in my own little world in this scenario, there's a really popular rugby event. I was at the Rugby World Cup in France about 6 years ago too. And there's so many people that need to come to this event that my on-premises infrastructure will not scale for it. And so what I need to do is build a cloud front end to my existing on-premises infrastructure. But things like customer records are still stored on premises, and I want them to stay on premises. So how do I take my existing on-premises application and make it scale to the cloud? So before we get to the architecture, let me just quickly demonstrate you how this application works. So you can see, firstly, I'm going to log in, as you'd expect, to a ticketing app. I go ahead and log in. And once I've logged in, then I'll go ahead and browse the appropriate place to go buy a ticket. We have internet. All we need is connection. The real question is, am I patient? Let me just see if I'm online. That isn't the world's best response. It appears I have no internet. Oh, look at that. Okay, great. Let's go back. So I'm logged in, which is what I just did. And once I've logged in, I can go ahead and choose some events. And so I'm going to go, in fact, buy some tickets for this rugby event. As you'd expect for any ticket purchasing scenario, I can select the level of seat that I want and the pricing for that seat. In this case, as I mentioned, I'm a big fan of rugby. I actually took my 3-month-old daughter to the Rugby World Cup in France and almost deafened her, I think, in the Stade de France. And so I'm going to choose some seats that are at the middle of the field. Not worried about the price because I'm a big fan. I'll go ahead and continue on that. And we're going to have a lot of fun if we're having network connectivity issues. Okay. There we go. And I'm going to choose my ticket, and I'm going to go to checkout and confirm my purchase. Okay? So a relatively simple scenario here. I log in as effectively an anonymous customer. However, in any of these ticketing type scenarios, there's also a second class of customer, which I tend to be, especially when it comes to rugby, who are VIPs. And as you would expect in a ticketing scenario, I'm going to have a mobile application as well as a web browsing application as well as a rich client Windows 8 application. So if I go here, let me just do this one more time for you. On my mobile phone, here I am. I'm already logged in now as a VIP account. A VIP account is identified because in the CRM system, it tells the system that I am a VIP. Okay, so in this case, I'm a VIP. Let's go see what happens when I go buy tickets as a VIP. So I go select the same thing, minimum price, maximum price, choose seats. I go select a seat that's available. I'll take that one. And what you will see here is that first there's determining final price really quickly up the top there, and it gives me a 25% discount. Okay? So I have two classes of users. I have the broad public that's coming in from the internet that gets the standard price, and I have a set of known users like me that are rugby enthusiasts that buy a lot of tickets that get a discount that's stored in my CRM system. Okay? I have a mobile app, I have a web app, and yeah, I'd have a Windows 8 app as well. So what does that look like from an architecture perspective? And this is actually it helps if I show you the slide. This is actually a really important slide to get in your head, because we're going to spend about 25 minutes walking the path through this application. So do spend some time here. The system labeled 1 is the CRM system. Okay? That is the system that effectively I query the user Scott Woodgate. Is he a VIP? Yes, no. If he is a VIP, then give him a discount. Okay? It is my on-premises CRM system. I have no desire to move my on-premises CRM system to the cloud. It's staying on-premises. Okay? So that's my on-premises system. On the left-hand side of the slide, as you're facing it, is what is effectively a Windows Azure website. Okay? This is where the web experience is delivered. It's delivered through websites and some scaled-out SQL databases, which I'll get to later. Okay? And then in addition to that, I have created some web API, RESTful services that sit on the side of that website and enable my mobile phone application to interact with it. Okay? So I have an on-premises CRM application. I have a Windows Azure website in the sky, and then I have a mobile application that's connected into that Windows Azure website in the sky. Okay. So I'm going to tour you through all three of these. The first thing I'm going to do is a whole bunch of setup, actually, but it's going to be focused on this on-premises CRM application. Because while this on-premises CRM application, I don't want to move to the cloud for production, it turns out that my development manager didn't give me enough hardware to go test the system on my local machine. Okay? Anybody developer in the audience doesn't get enough developer hardware to go build things? Yeah, it happened to me all the time, right? So what I'm going to do is take advantage of the recently announced MSDN offer, where I can have up to either 3 or 6 or even more than that machines running forever in the sky based on my level, and actually move that CRM system up into the cloud for development only. Okay? When I'm done, I'm just going to get rid of it and use the local copy. So let's go ahead and go through this scenario. I'm going to come back to it, but I hope you've got it in your head. So the first thing I want to do is actually go to Windows Azure. So if I go to Windows Azure, and you saw this in the keynote, but I'll just do it one more time for fun. Here I am in the Windows Azure console. If I wanted to create a virtual machine for that CRM system, I could go in here into the gallery and create a new virtual machine, and then I could go ahead and put the CRM system into it. And so I could simply do that by selecting this. You'll notice that as of today, there is the Release 2 preview. You'll also notice that the SQL CTP is there. This is the fastest, bar none, way to get your hands on the latest bits and play with them. So if you haven't already got yourself a Windows Azure account, I would thoroughly recommend it if you're looking to understand what the latest server and SQL bits are. So, and I'll give it actually a real, there we go. And we have to do this. Go ahead and create my VM. Give it a DNS name. Okay, great. Okay, cool. So that's the typical way in the user experience of creating a VM. In this case, I already have my CRM system running. It's already on premises, and it's actually already in a Hyper-V virtual machine. So I don't want to create a new one of these. What I want to do is take the one that I have on premises, copy it up to Windows Azure, hook it up, and get it going. Okay? So how do you do that? Well, let me show you. So the first thing you're going to do is, with some PowerShell, which I'll show you in a minute, upload the virtual machine. And the virtual machine will get uploaded into Azure Storage. Virtual machines in Windows Azure run on Azure Storage that provides them a lot of redundancy. For example, we take 3 copies of every artifact in Windows Azure Storage, so that if there is some physical hard disk failure in Windows Azure, we have 3 copies, 1 hard disk fails, you get the idea. And we replicate it back out. So inside this storage, what I've already done is executed a PowerShell command that will copy up the file that is the VHD file for that virtual machine. And we are going a little slow today, so while that's going, the command to do that, which I've already done, is this. Okay, this is a PowerShell script that goes ahead and adds the VHD up into Azure Storage. Come on, guys. Just do a quick refresh and see if that helps. There we go. Okay, and here you can see I have a variety of folders in storage. One of these folders is called Uploads. Underneath the Uploads folder, I've already uploaded that CRM virtual machine file that I had on premise. So it's there in Windows Azure. What I do next is take that VHD file, and if I was using the user experience, then I would go in here and I'd create a new disk, and I would go ahead and give my disk a name, my VM disk. I'd go ahead and point it back to that raw image file that's in the storage account in Uploads right there. And I would go ahead and say that it contains an operating system which makes sure that Windows Azure syspreps that image when it goes ahead and runs it. And I'd create the disk from the VM. And then I'd subsequently, the disk from the VHD. Then I'd subsequently create a VM from the disk. Okay? That's the steps. But I'm doing development and test. And I got to say, that's kind of a tedious way of doing it. And so rather than doing it that way, I'm going to go ahead and run a PowerShell script to make it all work. So let me go here into PowerShell. And if this is correctly cleaned up, I'm not going to explain all of the details of the script. I will show you a couple of things, though. One of them is to get access to your Azure information. What you want to do is first install the commandlets for PowerShell, and then it's important to go ahead and get your Azure publish settings file. Each subscription in Windows Azure has a publish setting file. The publish settings file contains the information that PowerShell needs to talk to it to go ahead and create items in your subscription. And so what PowerShell did there was redirect me to here. You can see here down at the bottom I have my publish settings file. And when I've got that, then I go ahead and import that publish settings file like this, publish settings file. And it's stored, I believe, in here. I just put it in my default downloads directory. And what was it? TE something? What is today's date? The 25th. It's probably that one then. Okay, cool. And so what that's doing is now setting up PowerShell so it's writing specifically in my account. Each of my accounts can have subscriptions in it. My subscription's TechEd 2013. I'm not going to go through all of the details in this, other than tell you at a high level what this is doing. It's taking that VHD file that was in the upload container, it's copying it to a second container, it's then making it into a disk, which is this, right there. It's then going ahead and creating a virtual machine, okay, right there. And it is actually putting the virtual machine into a private network as well, which I'll come and show you in a minute. Okay, and that's it. And so the advantage of this in PowerShell is that I don't have to remember all those commands. Yeah, that's interesting. I don't have to remember all those commands, and it looks like I didn't clean it up correctly. Multiple times just bear with me, I'm going to clean up and go it again. And I can just go ahead and run this one time, use it, run it again, and off I go. Just for the record, this is my cleanup script. You would do the same thing if you were in a dev test scenario. I want to delete it, start again, where I'm removing the virtual machine, removing the disk, and off I go. So this has a 60 seconds pause in it, and so we'll just wait for that to continue. While that's continuing, let me go back into the virtual machines and show you one that I already have running. Okay, so we'll recreate that one in a minute. This is one that I already have running that I created the same way. One of the things you'll notice here is that it does not have a connect button on it. A normal virtual machine that I would create in Windows Azure, such as the one that was the Windows Server preview virtual machine that I was creating before, and you'll see when I do a refresh, will automatically have a connect button in it. What the connect button has the capability to do is it enables you to RDP into that instance. Okay? So this one doesn't have the ability to RDP into it. Why is that? It's because, as Mark showed in the keynote, I don't want my CRM system to have any publicly accessible endpoints. Okay? This endpoints tag here, think of this like the firewall. If I had an 80, for instance, written there, it would mean I'm opening port 80 to the world. Or if I had the RDP port in here, I'd be opening RDP to the world. But this is my private virtual machine of CRM. I don't want the world over the internet to have any access to it whatsoever. I want to be able to tell my manager, I'm using the public cloud, but it's only me that can have any network access to this virtual machine at all. And to do that, I've taken advantage of the point-to-site networking capabilities that are available with Windows Azure. And so I've gone ahead and I've put this virtual machine inside a network. And so if I go do that, I will show you, sorry, let me just zip up here. I will show you how that network sets up. So we'll scroll down. And if I go look at networks, you'll see I've created a point-to-site network. You'll see within that point-to-site network, there's a couple of things I need to do. I go ahead and configure the namespaces that are in it from a subnet perspective. I put virtual machines when I create them with PowerShell inside those subnets right there. I download the VPN client, as Mark had already described. I run the VPN client. It looks like this. Just a really small download. And now that I've done this, I uniquely have access to my dev test machine. So if I do, actually I'll do this in Explorer. If I go to Explorer and do something like 10.1.4/C drive, then that virtual machine that's actually up in Windows Azure is acting like any other network share. Okay? You saw Mark remote debugger attached to it. Okay? I can similarly go ahead and now remote desktop from it, to it, sorry. Here I am remote desktoping to it. Once again, it's only I that can remote desktop into it. So let me see, that's fine, I don't know. Let's try that for a password. And of course, once I log into it, this is A, copy of Windows Server, just like you'd expect. You can do anything you want with it. And B, in my particular example, that little console application is my stubbed out CRM system. Okay? So inside this virtual machine, I've copied my CRM system, I've put it up in the cloud, and I'm going ahead and I'm showing it running. And if you look at this little debug output, every time the mobile phone calls through to the CRM application with a VIP login, then that 25% discount, you can see I've tried it a few times, is registered in the CRM application. Okay? So this is just normal Windows. You can do anything you want in here. I happen to have taken my CRM application up. Let me see if that PowerShell script will run, just to prove that I can do it in PowerShell as well. Apparently not. See if I can debug it on the spot. Huh, interesting. Okay, I'll work that through later. Okay, great. So we have, if I go back to the architecture, our virtual machine created. Okay, we have this now ready for development and test. It's up in the cloud. Let's go to the other side and look at the website and how we would put the website up. So I'm going to go into Visual Studio here. This is the first time that I've used this particular machine for source code control, and that's just really good. We seem to be having DNS issues. What I'm attempting to do here is pull down the source code from Team Foundation services. However, if I can't resolve Team Foundation services, that will be a challenge. So hold a second. Somebody took the internet out. Cute. Okay. Sorry about this, guys. It's tricky to show any of these demos without any network connectivity. 1, 2, 3, 1, 2, 3. Let me drop kick that. Okay, good. Let me do that again. That's good. Okay, so one more time. I'm in here in Visual Studio. This Team Explorer window gives me access to TFS Online. My source code is not installed on this PC at the moment. It's stored online. I want to go ahead and get the latest version of this whole thing. I want to put it in a directory on my local machine. Okay, and I'm literally, on real time for you, yanking down the project. I'll go ahead and run the project file. As we'll get all the items from source control copied down. There they go. And we're in. So one of the cool features here is taking advantage of Team Foundation Server Online. This is free for users of 5 or less users. And there's all my source code, except it gets odder and odder. Something went wrong with the by phones aspect, but we'll worry about that later. Okay, good. So let me show you what I've got here in terms of my project. So in here I have a number of projects. The first one, Buy Tickets, is the website. The second one should be the phone application that I was running. The third one is the CRM application. So let me focus on Buy Tickets. Buy Tickets is my ASP.NET website. You'll see a ton of folders here. If you aren't used to this, I'm actually taking advantage of ASP.NET MVC4. Okay? So the MVC4 framework, which I personally would recommend if you're building a new web application, enables you to create really easy to maintain code that sits on top of ASP.NET because it separates out 3 fundamental layers. One is the model. Here you can see a set of models. In fact, if I show you this, if I double click on seat model, I'm ordering tickets, and tickets go for seats. And seats have a set of data classes such as ID, event ID, section, level, row, etc. Okay? So the model is where I model my data. And in this case, I'm actually taking advantage of the entity framework, which is another feature inside the more recent versions of the .NET framework. And the internet's really getting me today, isn't it? And the entity framework enables me to generate directly from tables or directly to tables code. And so what I'm showing you here actually is a database, and you see those items in the database? Those are the seats items. This database was automatically generated by this model class because I was using the entity framework. And I can add additional attributes on the code pane, and because it's code first, it will go ahead and update the database schema as a result. And by the way, that database is not running on my local PC. That database is running up in Windows Azure. But you guys can't tell because the tooling makes it look exactly the same, right? So there's the database for my website. Here's my model that describes the data for seats. I similarly have models for purchasing and levels and the like, which are my data classes. That's the model in MVC. The second part of MVC in ASP.NET is the controllers. And the controllers control page flow as well as effectively shaping the data. So the most important controller in this particular application is, in fact, my seats controller. So my seats controller has methods like the purchase method in it, and that's the one I'll just take you through quickly. So if I look at the purchase method, without getting into all the details, I'm purchasing seats. What I do is I create a list of seats for an event and select that event, and then I iterate through each one of the seats that exist and add those that have been selected as seats to purchase. Because remember, there's a list of seats. I tick one to purchase. That's what this is doing. Adding that into the seat list. And then what I do is go ahead and look up the customer's profile on the CRM system. Okay? So this one line of code is actually pretty special. This one line of code is talking from Azure to my CRM system, from the cloud to on-premises. Okay? And I'll come back to you a little bit later on how it is doing that. But that's what it's doing. And then it's going ahead and taking the information in terms of the discount, doing some cookie work just to speed things up and closing. Okay? So that's an example of a method inside the controller that in this case is messaging some data. It enacts the purchase and takes that through. So that we have talked briefly about the models and the controllers. The third concept for the MVC framework is the views. And the views here are really quite nice. In fact, it's one of the reasons why MVC is a great way of building things. In that the view, of course, has the markup language in it, but then it also typically has reference to the models. So, for instance, I just chose the purchase CHTML view, and what you can see here is I'm iterating across each of the seats that were selected and displaying information on them, such as the section they're in, the row they're in, the pricing for them, and so on to the end user. And so by using the MVC approach with ASP.NET, I can create easily maintainable code that's also much easier to create portable code because I can take those controllers and reuse them, for example, or make modifications in the controllers separated from the models and the views. So that's ASP MVC4, key thing to be using. So that builds the user experience once again. That is for my portal. This user experience is MVC4. The second thing to talk about is really how did I get this up to the website? So how did I get up to the website? Well, why don't I make a change and we'll see if the internet lets me behave, and we'll see if we can demonstrate how I'm deploying this. So what I'm going to do here is actually go ahead and add, actually I'll add something a little bit later just to make sure that the internet doesn't mess me up. Let me go show you one more thing and I'll add. So here I am back on my screen. I've showed you the website. I'm going to show you the web API and then add some code to the web API. So the web API, by naming convention in ASP.NET projects, is going to be under a controller and then under a specific controller name. And what this web API does is provides a simple REST-based API service for any consuming client. It happens to be that I'm using a Windows 8 mobile phone, but I could use an Android, an iOS, anything that can consume a simple JSON-based code fragment, which I'll show you what that means in a minute. When I'm implementing Web API, I'm inheriting from the class API controller. And then I go ahead and create a set of methods. By convention, those methods are gets and puts. So for instance, I will have a RESTful method called getSeats that takes a set of parameters, event ID, level, da-da-da-da. I will have another RESTful method, putSeats, and you get the idea. In fact, those are the two that are in here right now. But what I want to do is actually add a third method in here that talks to how many seats are left. Like how many seats are sold overall and how many seats are left to purchase. That's more of a reporting method for an admin. So let me go ahead and first add a model that talks about, we'll call it seat summary. And so if I go into the models, I can go ahead and add a class. and we'll call it the seat summary class, or the seat summary model, and we've done that. And just to save me some time, although I could probably have typed this one, my model's pretty simple here. If I'm looking for the seats that are currently sold and the seats currently remaining, that seems like a reasonable thing to do, to summarize for an admin, how many tickets are left. So we've created that new class. Go ahead and save that. Now I'll go back to my seat controller under my web API, and somewhere about there, I'll go ahead and throw some code just with quick IntelliSense. And what this does, not what that does, what this does is go ahead and summarizes the seats that are currently sold. Now, one thing, if you are reading quickly, that you might be curious about is, why am I going through these multiple levels? Do you see that I go look at level 100, look at level 200, and look at level 300 as I iterate through the seats sold? Well, that refers to the stadium. My stadium has 3 different levels in it, 100, 200, 300. But it also refers to the architecture of the application. I'm taking advantage of not a feature, but an architectural design pattern called sharding. Rather than having a single SQL database for my website, I'm expecting a tremendous amount of traffic on my website. And so I actually have not one database, but 3 databases. Do you guys see the 3 databases right there? Okay. One of the things that was probably pretty hard to do, and not many people did historically before the public cloud, was just spin up another whole SQL database. With the public cloud, it's very easy to say, I want 3 whole SQL databases. Why would I do that? At some point, lock contention gets in your road, and now you have 3 completely separate databases. How do I use those 3 databases? I basically round robin. If a customer is in the 100 level, or for the seats that are in the 100 level, they're stored in the 100 level database. The seats that are at the 200 level, they're stored at the 200 level database. Seats are at the 300 level, you get the idea. They're in the 300 level database. So what this does is gives me scale in the data layer. So later on in the talk, I'm going to show you scale in the web layer, where I scale out the website. I won't have to, when I do that, scale out my data layer, because I've already scaled it out. If I needed more scale, I might go down to half a level. So the seats on the left-hand side of the stadium only are in one database, and the right-hand side are in another database per layer, and make 6 databases. But this is a fairly typical design pattern when you're building for scale, and it's relatively easy to manage in code. As you can see, you iterate here across 3 levels to go make it work. As you'd expect in my web.config, I have 3 different connection strings right there. They are pointing to Windows Azure, by the way. They look all the same to everybody else, but that's a Windows Azure set of PaaS databases. And then there's some deeper code somewhere in here. It's in the seats repository right here, that goes ahead and acts as a little helper method, setting up the connection string based on the level put in. So if this is setting up the connection string and it gets called, so when I select by level, the first thing it does is check what connection string it should be using and then pulling it through. So not a lot of code here needs to be written, but from a scale perspective, suddenly I've scaled out my data layer quite substantially by taking advantage of multiple SQL servers. And by the way, while I'm on that topic, you know how fast it is to create a SQL server? Let's see if I can show you. So if I go here to, whoops, back up here. If I go back up here, and actually while I'm at it, why don't I show you how fast it is to create a website. Website, create, my new web, TechEd. Yep, I can do that, boom. When I was telling you earlier that time to market is a big deal in the cloud, this is what I mean. I don't know too many people who can put a website literally up on the public internet literally in 7 seconds. And what I just did was put a public website on the internet in 7 seconds. Now, it's a template, but with a very simple publish from visualstudio.net, in another 10 seconds I can have my whole website up there. Very, very fast. And taking that same example, if I just go show you for the SQL servers why it is so simple and easy to create SQL servers. So we go back in here. I can go ahead and choose a SQL database. And just to be clear, this is a PAS SQL database, otherwise known as SQL running on Windows Azure, as opposed to a SQL running on Windows itself. And it's funny, the only thing that isn't loading is the thing I want to use. Doesn't that happen? Come on, guys. There we go. Okay, good. And here you can see those SQL databases that are already created. If I want to create a new one, I go ahead to quick create. Scott, whoa, DB1. That should do it. Boom. And I don't know, 7, 8, 9, 10, I think it might be 13 seconds later, I have a database online ready to go. So this is a really, really big deal. And like, how many people can get a database up and going in their system for production in 20 minutes? A few of you? A day? A couple days? Is anybody listening to me? A week? There we go. A couple of weeks. A month? Okay. Yeah. This is what is one of the big, big advantages of the cloud. Even if you don't need the scale aspect of the cloud, the fact that you can really, really quickly get a website up there, really, really quickly get a database up there, means that you're just not wasting time. You're getting your work done much, much, much faster with the cloud. Okay, cool. I went a little bit of a tangent there. Let me go back. So I've made some changes, as you'll recall. I've added a seat summary class. Let me see if this builds. I have no idea what actually came out of the mix. And the way I'm going to build it, if I can, is to check it in. And so let me, please build, please. So as you can see, the changes that I've made here are to the seat controller and that new class that I added. And I am checking it in. And what happens when I check it in is that those check-ins are, let's see, local version is this. Let's take the server version. Let's do that. And let's do that again. Oh, actually, hang on. I lost my model, didn't I? Let's do that one more time. There we go. Oh, I'm not in a happy place. Okay. So let me get out of that. What I was going to show you, and maybe challenging without pulling this all down again because it looks like my pull was messed up, was the fact that you can actually have Team Foundation Server online build the code for you. And so rather than me doing a typical build locally, yeah, that's hilarious, I would go ahead and send it up to the cloud to have it built. And when I do, then up here in the cloud, this is Team Foundation Server. It would go ahead and build my project and talk to Windows Azure to deploy my project. And I'm just going to look at it one more time and see if I can figure it out on the fly. So we're in here. Dun, 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 dun. Yeah, it's not going to work. No, it's going to take me too long to re-pull it. So that's a shame. You'll have to come see that from me a little bit later. But effectively, what I would do is go into here, add a file, see if I can just do something random. Through model, just here, and add a class. I'm just going to add a new class. And we'll put that in there again. And we'll do the model code. Okay, good. So now I've got a changed file. And now when I go check in, like so, saves the file. It notices the class has changed. Build me. I choose check in. Go. Okay. This has actually worked. So now it has literally taken that change request up to TFS Online. And if I go up to the build on TFS Online and I look at queued, you'll see that there's a build queued here for me. Okay? So my compile build step is not running locally. It's running online. I have no idea whether this will work, given that it looked like my pull was a little corrupted. This typically takes 5 to 10 minutes to do its thing. What it does first is build it, and then the second thing it does, which is actually extra cool, is hooks it into Azure. So if I go back to my websites, the website that I just set off for deployment is this Ekata One website. Okay, that's the website that I demoed for you at the beginning. And it has, right now, an active deployment going on. Okay, so I do a check-in to TFS. TFS does a build. That build is then transferred into Windows Azure, and those changes are live. Okay, all magically like that. Which is an incredibly efficient way of making changes. And what's more, if something goes wrong, like it did when my connectivity went wonky, I can actually roll back my builds and get back to a good known state. So big advantage there in using TFS and some really super integration with Windows Azure. I have a backup, because you always should, of the website just to show you what that change would look like. And so if I go here, seats, get seats, summary, something like that. If I can spell, Ekata. Oh, that's good to know. This is how you call the web API. Okay, so you call the website name WAC API, and then the method that you're calling. And then should our connectivity come back, that would be bringing back a JSON file that has the number of seats that are available. But it does appear that I have all types of gremlins today. Just to show you on the Windows Phone side how that works, if I go over, oh, I don't even know, I can't even get the project. That's a shame. You guys want to see some cleanup live on stage? Let's try that again. I just deleted my checkout. I'm going to go get latest version. TE work. Do that. No, it doesn't like me today. Sorry, guys. In the Windows Phone app, what I do is effectively use the web client API to call. I'm just trying to figure out how I can show you that in a different way. Oh, I know how. To call the RESTful service, which exposes the endpoint. See if this works. No. That's fine, I don't mind. So look at that. Okay, this is a local copy that I just happen to have, so you can actually see it. If this is the Windows Phone application, okay, that we're having trouble loading. If I go look in, for example, the seats page for the Windows Phone application, it's actually right here. Then the way that I get the seats information from the phone is I construct a URI string that has event ID, level, minimum price, maximum price. Okay, those are the methods of the RESTful call. I instantiate a new web client, and then I go ahead and call this URI string. And if I go Shift F2 on that URI string, you'll see that the URI is composed of my website name, HTTP, my website name, WAC API, WAC seats, and off I go. Okay, so my phone client is simply calling the RESTful APIs and receiving back JSON, which it then goes and deserializes just down below here, actually. It's just deserializing it in that async method just there. And so that's how it works in terms of the phone talking in. So if I go back, we have a website created in Windows Azure. We have a set of web APIs running in Windows Azure. We have a phone application that is using those web APIs and calling those web APIs. we have some magic going on that I haven't told you about yet that enables that method call to the CRM application from the purchase method. I'll talk about that in just a second. And we have these databases. Once again, this is not a database in this architecture. It's actually 3 sets of databases. So what's going on in here? What's going on here is I'm taking advantage of a feature of Windows Azure called the Service Bus. It was mentioned in the keynote. The Service Bus has 2 functions. One of those functions is an asynchronous message mechanism. Think about it as MSMQ or MQ series in the cloud. You put a message in it and you pull a message off it. Okay? And there's an asynchronous nature to it. So you can use this when you're building a multi-tier application, and you typically do this in the cloud when you might overwhelm a back-end system. Put things all in the queue, have the back-end system sip off the queue. That way your front end stays up the whole time. That's one feature it does. I'm actually not using that feature today. The feature I'm using is something called a Service Bus Relay. And what a Service Bus Relay does is enables you to expose a data contract of the specific information that you have in the back end that you want to make available in the cloud. And in this particular case, I do not want all of my CRM data to be exposed up in the cloud. I don't want it all. I want very specific information. I want to know whether that customer was a VIP, and that's it. I don't want their address information. I don't want their financial information. I've just decided that all I want is this customer email address a VIP? And so I've created a WCF service that's running over Service Bus that takes the information from the CRM system and makes it available to the client, which is running in Windows Azure. Okay? And so if you go back, if I still have I disconnected from the VPN. When I was in the VPN showing you that console app, that's one of the endpoints. That's actually the Service Bus endpoint for this. The other endpoint for this is in Windows Azure itself. And so if you go back into Windows Azure, you will see a set of features down here, which is called Service Bus. And in Service Bus, I have a relay set up just here, the CRM vAPI. And so this is a super important thing to use, as I say, when exposing data. And it's set up here, and then you write a little bit of code to it, and off you go in terms of connecting the systems together. This is something that EasyJet, the Halo guys who use our technologies, and a number of other customers take advantage of a lot when they're building. So with that, let me just see. I know we had a few things go wrong there, which I'll see if I can recover in a minute while we do something fun. But what I've built here is an architecture that is both scalable in the web tier, and at the moment it's actually only running on one web server, but I'll show you shortly in terms of how it scales out, that connects back to my on-premises application. I've taken advantage of dev test in my CRM application in the cloud, even though I'm never ever going to deploy it in the cloud. I think it's a really important takeaway. You can use the cloud for dev test, even if you're never ever going to use the cloud for production. And it just gives you that extra hardware that you might not have under your desk. I'm also taking advantage of a feature called SQL Data Sync. What SQL Data Sync does is gives them the ability to select 2 different databases and 2 different tables within those databases, either on-premises in the cloud or both in the cloud, and synchronize the tables. And so if there's a subset of event information, which is what I'm using it for, that's in my CRM system that I want to make available in the cloud, then I can just set up a SQL data sync between those 2 endpoints, and it'll just go ahead and automatically synchronize that information for me at a table level. Okay, so that's it. So there was a lot there, and I knew I'd be bouncing around the code a little bit, so I thought I'd pause here and do a quick giveaway. Somebody under their seats, I hope, and if not, look to the seat next to you if there's an empty one, there are a couple, has a business card of one of my colleagues. If you have a white Microsoft business card, it's about this big, somewhere under your seat, feel free to look. Then you won a pretty fancy bike, so feel free to look on the next person's seat. I know, don't get too uncomfortable about it. I assure you there's one out there somewhere. It's right under the bottom of the seats. You got it? Okay, cool. So come up to, where's Craig actually? Oh, okay. See the guy there? Actually, just come up to me at the end of the presentation and we'll hook you up with it. We'll have to ship it to you. But congrats, that's yours. And just for the record, these guys use the Azure stuff in their point-of-sale systems and have a lot of nice things to say about it. Okay, I want to do a change now and move away from the scenario and talk a little bit more on prescriptive guidance, because I hear lots of people saying, hey, you Microsoft guys aren't very prescriptive on what we should use. And so I want to get a little prescriptive in a number of areas. I'll start at user experience and I'll go across. Okay? And this is like, if you think of the overall application platform, what should I use? How do I think about that? And so I have some advice. It may not decode everything you want to know, but how many people build .NET apps that are UI-centric apps? Okay, this is for you guys. It relatively well applies to website applications as well. The first piece of advice is the same advice I was giving when I was building my ASP.NET MVC v4 app, which is do use the model view paradigms. On the desktop specifically, that means MVVM. Okay, that's the WPF technology model view model. Use that. It really enables stronger portability, separation of code, and as you migrate to future frameworks, it just makes it much easier to do that. Obviously, in ASP.NET, use MVC. It's a big deal there. When I think about .NET, how many people know what portable libraries are? Like, there's a literal thing called, yeah, good, okay. In the latest, well, until today or tomorrow when you get Visual Studio 2013, in the current production version of Visual Studio, there's a feature called portable libraries. When you do file new, literally portable library, it will take a subset of the .NET framework that works across the phone, across Xbox, across the PC, and give you that subset to work with. It means that you can have a core of code, even if it isn't 100% of your code, that is literally portable across platforms. And then you can also, of course, have a core of your code that isn't portable, that you hook to that. So taking advantage of portable libraries really does save you some time. It goes without saying, and we have some more work to do on our little ticket scenario in terms of making a beautiful user experience, that a modern UI is critical these days, and it's certainly achievable both to the desktop and beyond that. From a code perspective, as you're looking at legacy applications, do look at what you can move to the server. Okay? And that can be the server on premises or on the cloud. Obviously gives you more flexibility, certainly gives you more power. Probably the best example of that, I think the Xbox guys with the Xbox One announcement were making comments along the lines of quadrupling the power of the Xbox by the computing that's available to them in the cloud. And actually a number of the things that they do, including media, is actually built on top of Windows Azure. So it's a good example to separate the code. It gives you more scale. It gives you cross-platform device availability if you're using multiple devices, back-end and so on. So there's my view on the front end. I'm not going to do the WPF versus HTML JavaScript. I think the answer is yes, and it depends where you're coming from and where you're going to. I don't think there's a clear always use HTML JavaScript or vice versa answer to that question before someone asks me. Okay, from a data layer perspective, this is the area where I think we've had the biggest explosion of Microsoft solutions in the last couple of years. The solid key product here is SQL Server, and we just keep innovating and innovating and innovating in the mission-critical aspects of that product. Certainly, you can run SQL Server in a virtual machine on Windows Azure, and we expect lots of people will be doing that. I will tell you that SQL Server or Windows Azure in general is limited in terms of the amount of memory it has in a virtual machine to 56 or 8 gigabytes. So if you have a workload on SQL Server that's greater than that, then you want to use on-premise, either in a VM or in physical hardware. If you have SQL workloads that have less than 8 cores and 56 gigs, then you absolutely can run them very well on Windows Azure. The second category of database, which is the one I was using in this example for in the cloud, is the PAS database that comes with Windows Azure. This is a subset of the full SQL Server. It does not do, for instance, a lot of the analytics aspects. It's more focused on OLTP. And it is It has the advantage that it's a PaaS database. What that basically means is you don't have to worry about the patching aspects, the operating system aspects of it. We take care of it. You just have to worry about your tables and manipulation of the data inside of that, which is obviously a management advantage. But once again, it does not have the full set of features, particularly in BI, that the full SQL Server has. For instance, analysis services. We talked about HD Insight, basically the Microsoft branded Hadoop. This also runs in Windows Azure. So easy setup here on Windows Azure. In fact, I don't know why you would set it up anywhere else. It's not the easiest thing in the world to set up, but it is fairly easy to set up, actually very easy to set up on Windows Azure. For unstructured data, I think Aaron demonstrated some of that in the keynote. Anything from word counts through to patterns of TechEd attendees is good there. We do have NoSQL support. So Windows Azure has inside it a key value pair store called a table. So where you don't have a highly query rich, for example, and what you want to do is non-relational data in key value pairs at high scale, then Windows Azure tables enable you to do that. They're very inexpensive. This is unstructured once again. It's structured, but it's non-relational data. And then the final category is blobs. And actually, almost everything in Windows Azure feels like it's a blob. The virtual machines that we were creating in Windows Azure are stored as blobs in Windows Azure. Okay? Any media that you create in Windows Azure is going to be stored as a blob in Windows Azure. So blobs are a very scalable mechanism for storing lots of information in Windows Azure. And like anything in the Windows Azure file system, we triplicate the writes. And so they have really strong redundancies. You can also geo-sync them to other locations. So use the right tools for the right jobs there. You certainly have a broad set of tools available to you to drive through the data layer. The next area I want to talk to quickly is the syncing aspect. So how do you get data from SQL on premises to in the cloud? Aaron talked to this briefly. There's a new feature called Always On. Go check it out. Always On gives you the ability to connect from SQL either running physically or virtually on premises up into a VM in the cloud. Today it's a DR scenario. Somewhere in the future it'll be a high availability scenario where we'll be able to auto switch if there's a failure happening locally. You can also take advantage of SQL data sync. That's what I did in the demo. Moving tables, synchronizing data and tables across the cloud. You can do full backups of SQL databases up in the cloud. Okay, so use the backup capability. And then finally, you can do this thing that's kind of the baby step. It's even before IaaS on SQL in the cloud, where SQL and the SQL agent stuff runs locally. So all of your applications don't have to be changed. Not even the connection strings have to be changed. But the data files and the log files specifically for SQL are running in Azure. So the advantage this has is literally you don't change any application. However, you've taken the data and the log files and you've put it up into the cloud. So there's really a broad set of options here depending on where you are on the dial of synchronizing with or moving to the cloud for a specific work source in the context of SQL. And there's a few others, obviously SSIS and a few other things that I could have put up in the list. From an integration perspective, there's WCF and Web API. If you're starting today and for most requirements, I would strongly recommend going with Web API. It's a very simple user experience. Certainly you can do lots of amazing, powerful things with WCF. But Web API has got a lot of simplicity going for it, and we continue to innovate there. Service Bus I talked to earlier, so I won't comment on that. Workflow, BizTalk, and we also just announced BizTalk services up in the cloud are available as well. So EDI integration available in the cloud in preview. Unless I get kicked off, which I might do given the time, I'm going to see if I can try one more demo, which is a load test. And so the notion here, as I was saying earlier, is that the SQL servers are scaled out for our workload. But what about the websites? And so for Windows Azure, if I can get internet working, for Windows Azure, it's very, very easy to scale out your website. And literally, you can go from the smallest website in the world to one that would be in the top 10% of websites globally as easy as pulling a slider. Literally, if I use the Scale tab, which it looks like I'm already on, that's good, on Windows Azure, see the Scale tab? if I go do this, and then I take it to 4 cores and 7 gigs of memory per website instead of 1.7, and then I scoot it up to 10, then I just met the business requirements of 90% of all of the websites in the world. And by the way, if anyone in the audience is running one of the top 10 websites and the 10% websites in the world and wants that to be 11, 12, or 13, come talk to me. We just created a somewhat artificial limit. So what this little dial does is actually kind of neat. It's literally going to scale out my website in real time. But before I show you that in operation, let me keep it at where it is today, which I believe was 1 instance when I came on in. Okay, so it's a small site. And let me demonstrate some load on it. So this is something Brian showed you in the keynote, and so I'll go relatively quickly. But what I'm doing here is running a load test against my TechEd website that I created, assuming it's alive. And given that I have put, if you see down here, 1,000 simultaneous requests on it, that is, not something I can do from this desktop or laptop. There's about 250 requests per core. I have 2 cores on my laptop, so I couldn't do it from my laptop. So I'm taking advantage of TFS online in the cloud. The cloud is actually being the load host as well as the load client. Okay? TFS is hitting Azure, is what's going on here. It's instantiating 4 agents, 250 users per agent, for 1,000 users, hitting my website, which is TechEd.com. It is not going to survive very well with a single setup that it has at the moment. And so what you will see with usually about a 20-second lag if things are working before the reporting starts coming, is that the average page response times, start doing that. Things start going up and up and up and up. And like that. Tick that along. Takes about every 30 seconds. And it looks like my website's dead, which doesn't help. That's just the number of users. Okay. Well, it looks like it's really having some trouble today. What you would typically see here is my load going up like this, but in one of my deployments, I literally broke the website, and so it is not working. Just to demonstrate the scale aspect, the way I do scale it is to go here, choose the number of instances I want, press save, and I'm done. And that is the power of the cloud. I literally went from creating a website in 7 seconds to scaling a website to take massive load in 7 seconds. Okay? It's like my daughter could play with this dial and not have any idea what she's doing as a 6-year-old. But fundamentally, we are now out there using the REST calls that come from the portal and scaling this out across the Azure infrastructure so that it can handle the largest load. So with that as context, I want to close. I appreciate your patience as we had some connectivity challenges today for sure. If I had some broader takeaways, the first one is, guys, you need to play with these new technologies. How many people are using ASP.NET MVC4? Bunch of folks? Okay. Great. How many people are using Web API? Cool. How many people are using Windows Azure? Cool. How many people are going to use Windows Azure with either SQL or Windows Server in a virtual machine in the next week? There you go. Yeah. Get out there and play with these technologies. It really isn't that hard. That whole solution that I showed you was built in about a week and a half with 1.5 people. So it is really simple to go build these solutions these days and do that. And certainly do start thinking about scenarios that you can take advantage of the best worlds. The easiest one to get started with is dev test. Take your dev test workload, put that secure point-to-point VPN, put those virtual machines up in the cloud, try it. See if you like it. Just try it. And then go beyond that. Start thinking about inside your business, what are the scenarios that you can connect on premises to in the cloud and get value of both of those scenarios and be a leader in that context. Welcome any questions, and thanks very much for listening. Cheers.